like your soul when it's shirtless, 'cause it's just like mine.
What's up guys, I'm Nishit Tarantula and I'm on YouTube back again, and in this video I'll begin to tell you special relativity and the derivations of E equals MC², which is the most famous equation given by Professor Einstein in 1905. Alright, so in the first part, because this video is divided into many parts, so in the first part I will be telling you the practical special relativity, and then let's see where we'll move on. Right. Just imagine there's a vehicle, and inside that vehicle there's your friend S prime, and you are here, it's you in an S frame of reference. Well, I just wanna tell you that special relativity only works in an inertial reference frame. An inertial reference frame means the frame which is not accelerating, which is moving with a constant velocity. Alright, your friend is S prime and you are S. The vehicle is moving at velocity v. Suppose there's a ball with S prime, and if he rolls the ball at a speed u in his perspectives along with the direction of the vehicle, so what would be the speed of the ball? Well, you will just measure the speed of the ball in your perspectives. Speed of the ball in your perspectives will be v plus u. So if v equals 60 meters per second plus u is 2 meters per second, you will observe the velocity of the ball as 62 meters per second. According to you, the ball is moving at 62 meters per second. Now if you just turn the situation from now S prime rolls the ball to the opposite direction at the same speed, what you'll observe? Well, the speed of the ball will now be v minus u. 60 minus 2 meters per second. That is equals to 58 meters per second. Now there's an interesting thing, that the speed of the ball in the perspective of S prime and in your perspective, S's perspective, the speed of the ball is constant. But instead the ball, if you take light, what will happen? What will happen if you take light? Light is denoted by letter C, which is constant, equals to 3 times 10 to the 8 meters per second. Speed of light is constant. Well, there was an experiment conducted by two scientists, Edward and Michaelson. There was something like that. It was known as the Michelson and Morley experiment. It was known as the Michelson and Morley experiment. What they did, that they were in search for an ether. What an ether is? Well, if you just take an example of any energy, like for example sound. Sound needs a medium to travel. Sound in vacuum cannot propagate. It either needs air, water, or any solid substance, etc. So they tried to find that does light requires a medium which is called as ether, and it was known as the Michelson and Morley experiment, and this is the world's famous failed experiment. Yeah, this experiment failed. An interesting thing is that this is very important experiment which failed, but it gave you another idea about light, that the speed of light is constant. About this, if you want to know about this experiment, just check out the description box. There's a video on Aether. Search for Aether, Michelson and Morley experiment, something like that. So in that experiment, they found that the speed of light is constant. And if I just give you this situation once again, you will say that the speed of light will be v plus c. That will be wrong, because the speed of light is constant. That means something have to change, and that's the time which is changing actually, and that led to the discovery of special relativity by Professor Einstein in 1905. That means time is not absolute. Now, once again, take a vehicle, S prime frame of reference, and it's your vehicle, S frame of reference. S prime is moving at velocity v, and you are at rest. That means velocity equals 0. When this S prime will come here, there will be a flashlight which will reach towards both of you, S and S prime. Alright, if the distance between you and S prime is x, and the distance between S prime and this light is x prime, suppose. So if I say you have to find out x, so the equation will be something like this: x equals x prime, that means this distance, plus this distance here. But what's that? We know that distance is speed multiplied the time, so we can do the same here. The speed in a time t, that will be vt prime. In his perspective, it's t prime. So x is equals x prime plus vt prime, and if you have to find x prime, that will be just x minus vt. Now we have to multiply both the two equations with a term gamma. Gamma is a Greek letter which was given by the Michaelson and Morley experiment, because here the speed of ball was not constant, but the speed of light is constant. That means something have to change it, and that's the time which is changing. And due to different results, we are using this gamma term. So if you just multiply both the equations with gamma, we'll have x equals x prime plus vt prime times gamma, and x prime equals x minus vt times gamma. It's gamma. Alright, now if you just multiply both the equations with each other, we will simply have x prime equals gamma squared times x prime plus vt prime times x minus vt. And by simplifying this a bit more, that means multiplying both the two, we'll have x prime equals gamma squared times x prime x plus vt prime x minus x prime vt minus v square t prime t. Oh no, I'm so sorry. Alright, note it down if you want. Now, as we know that time is distance over the velocity, and t prime velocity distance prime over velocity, so we have to substitute t and t prime here with this equation. Now we'll get x prime equals gamma square x prime x plus v x prime over c times x minus x prime v x over c minus v square x over c times x prime over c. Alright, Now if we just divided everything by this thing, x prime, we will get 1 equals gamma squared times, that will just give us, 1 plus v over c minus v over c minus v square c square. And for making an equation for gamma, not gamma squared, just gamma, we will have our equation gamma equals 1 over under root 1 minus v square over c square. And this is known as the Lorenz transform. It was all in the first video, and I will meet you in the second one. Stay connected.